Good morning, student. We are running the series of engineering mathematics. That name is exam decoder for particularly discrete mathematics. In today's lecture, let us start to discuss one question. That question have the 5 mark weightage. These 5 mark weightage questions we want to discuss in today's lectures. What is questions are given? Questions number 4 is question determine the whether relation R whose matrix representation are given and it is reflexive, irreflexive, symmetric, asymmetric, and transitive where A are given. A is 1, 2, 3, 4. Means it is question is asking in question the matrix representation of relations are given and he is asking the check the that relations is reflexive or not, that relation is irreflexive or not, that relation is symmetric or not, that relation is asymmetric or not, that relation is a transitive or not transitive. We want to check further for that. In these lectures we are starting to discuss for that relations. Means in write down the solution for the given question. A is a set and that whatever may be the relations which are representing here in the matrix form, that relations are defined on this set A. Okay, means mr the matrix representation mr 1 2 3 4 this element of that set 1 2 3 4 this element we form set A. And what is now we want to convert that matrix representation into relation, means that matrix representation of relation. So let us convert that relation into set format. Now the how to convert one here in this matrix forms, in this matrix 1 and 0 are element are available, only 1 and 0. 1 means those element are relations are exist, 0 means relation or does not exist. What is one representation? One represent relations are exist in between these two elements. And what is zero represent? Zero represent there is no relation or exist. Then how to convert that relation matrix into uh, set format? Let us for one are available. This one represent one is related to one. Therefore, write down first element one is related to it. One. This how what this is one represent one is related to two. Therefore, second element we are writing here one is related to two. 1 does not related to 3. This 0 represent there is no relation between 1 and 3. There is no relation between 1 and 3. There does not exist element in between this relation. Means there is no relation. Now 1 are available for here. There is relation between 1 and 4. This is what is next element? 1 comma 4. 1 comma 4 is third element. Now go to towards second. 2. 1 are available. 2 is related to 1. Therefore, write 2 is related to 1. 1 is representing relations are exist. 2 is related to 2. Second element is 2 is related to 2. There is no relation between 2 and 3, 2 and 4. Now, go towards 3. 3. There is no relation in between 3 and 0, 3 and 1, 3 and 2. 3 and 3 relations are exist. Means 3, comma 3 are next element in your relation. Now 4 is related to 1. 4 comma 1. 4 comma 1 is next element. And there is no relation between the 4 and 2. There is no relation between the 4 and 3. The relations are exist between 4 and 4. Therefore, next element is 4 comma 4. Okay. Now go towards next. Means now this is the relations R. We are convert that given matrix into relation format. Now we want to check that relations are reflexive, irreflexive, transitive, or asymmetric. We want to check, comment on that. Let us start for checking. Since if you observe that relations, in that relation 1 are exist, 2 are exist, 1 are available, one self-related element are available in that relations. Mean 1 is related to 1, 2 is related to 2, this element, 3 is related to 3, and 4 is related to 4. If 1 is related to 2, 1 is related to 1, 2 is related to 2, 3 is related to 3, 4 is related to 4, which are available in that relation. Therefore, that relations are reflexive relation. That relations are reflexive relation. Why that relations are reflexive relation? Because all element which are belong to set, that all elements which are self related, all self related element which are available in given set. Okay, there are four elements which are belonging to in original set A. We are defining relations R. In that R, self relations are exist. Self relations element are exist means in simply we call that 1 1 2 2 3 3 4 4 element are exist. Therefore, this relation is reflexive. Okay. Now we want to comment on the that irreflexive relations. If relations are reflexive, self-related element are exist. So reflexive, that get reflexive. Now we want to comment on irreflexive. What is meaning for irreflexive? Irreflexive relation, if you want to check the irreflexive relation, in that relation, self-related element does not exist. If the self-related element does not exist, we can call that relation is irreflexive. But if you are observe that relations, given relations, 1 1 element are exist means self-related element are exist in that relations. Therefore, this relations is not irreflexive. Here we write down that reflexive is not irreflexive. Let us correction. Make this correction in this PDF. This is a reflection question number 2. 1 1 R belongs to R. Therefore, this R is not reflexive. R is not reflexive. Therefore, this R is not reflexive. Make this correction for this. Make this correction. Now, third, we want to check on symmetric. That relations, given relation is symmetric or not. We want to comment on that. Okay. What is symmetric relations are talking about? If other than self-related element, whatever element are present, exactly symmetric element must be present in that relation. Okay, other than this self-related element. Let us observe for this original relation. What is original relation? Self-related element 1 1 1 1 1 1 2 2 3 3 and 4 4. This is self-related element. Other than this, four element are available. Let us choose the element that is 1 1 comma 2. 1 comma 2 is element which is belongs to R. If you want to say that this is a symmetric property get satisfied this relation, 2 comma 1 also available in that relation. If 2 comma 1 is available, then we call that symmetric element are available. If 1 comma 2, 2 comma 1 is available in that relation. Next element is 4 comma 1. 4 comma 1 and 1 comma 4 also available in that relation. Okay. Means symmetric element are available. Symmetric property gets satisfied. 1 comma 2 available, then 2 comma 1 also available. 1 comma 4 available, then 4 comma 1 also available. Okay. Therefore, that relation is symmetric relation. Let us comment that relation, given relation is symmetric relation. Then how to write that relation is symmetric relation? Okay. Let us think that 1 comma 2 belongs to R. It implies that 2 comma 1 also belongs to R. 1 comma 4 belongs to R, or 4 comma 1 belongs to R. It implies that 1 comma 4 also belongs to R. Therefore, we conclude that that relation is satisfying the symmetric property. Therefore, that relation is symmetric relation. That relation is symmetric relation. Now we want to comment on asymmetric relation. What is asymmetric relation is talking about? In asymmetric relation, if A is related to B, then B does not related to A. B does not related to A. That type of relation is called an asymmetric relation. In asymmetric relation, symmetricity property does not satisfy any element which are belongs to that relation. Means in simply, we want to check that relation is asymmetric or not. First, let us observe the self-related element which are available in that relation is not asymmetric. In anti-symmetric relation, self-related symmetricity property does not satisfy, and asymmetric relation also symmetricity property does not satisfy. But there exists a difference between anti-symmetric and asymmetric relation. In anti-symmetric relation, self-related element are allowed. Means self-related element can also available in that anti-symmetric. But asymmetric relation, self-related element does not exist. Does not exist. Means this is for means A is related to B. If A is related to B, then B does not related to A. That type of relation is called an anti-symmetric relation. If you observe 1 comma 1, 1 comma 1 is belongs to R. Therefore, self-related element which are belongs to in your given relation, self-related element are belongs to in your relation. Therefore, this relation is not a symmetric relation. Therefore, that relation is not a asymmetric relation. Now, next a comment for transitivity property. What is transitivity property is talking about? If A is related to B, B is related to C. If A is related to B and same time B is related to C, then there must be exist element A is directly related to C. This is according to transitivity property. Means A is related to B, B is related to C, then directly there exists a relation between A and C. A and C. Let us start to check the given relations is a transitive relations or not. If you want to say the given relations is a transitive relations, then whatever may be the possibles, the combinations are become, we want to check all the possible combinations, the transitive property must be satisfied. If you want to say this property is this relation is not a transitive relation, if you are able to show one examples, means one pair there exists in that relations that does not satisfy transitive property, then we directly comment that relation is not a transitive. Let us check for one by one. 1 comma 1 is also available in that given relations. If you observe that relation, okay, let us try to check the original relations are, okay. After that we are checking directly 1 comma 1, 1 comma 1 is 1 comma 1 is available in that relation. 1 comma 1 and 1 comma 2 is two different element for relations. If you are choosing these two different element 1 comma 1 and 1 comma 2, means A is related to B and B is related to C. What is directly concluded for that? A is directly related to C. This is by according to transitive property. Let us check that element. Okay. If 1 comma 1, 1 comma 1 and 1 comma 2, which are belongs to is belongs to R. But what is the resultant for that directly? A is means 1 is related to 2. This is result for that. Means A is related to B, B is related to C. That is imply A is directly related to C. This is the result for that, which is also belongs to R. Okay. Now A is related, 1 is related to 1 and 1 is related to 4, which are belongs to R. But 1 comma 4, this is the result for this. Means A is directly related to 4. Means 1 is directly related to 4 by transitive property. 1 comma 4, which are also belongs to R. 1 comma 2, 1 comma 2 which are belongs to you in your original relation, and 2 comma 1 which are also belongs to in your original relation. By according to transitive property, A is related to B, B is related to C. That is imply A is directly related to C. Means 1 comma 1, 1 comma 1 is means A is directly related to C. Then 1 comma 1 which are also belongs to in your relation. The 1 comma 1 is available in your relation. Okay. 1 comma 2 and 2 comma 2, 1 comma 2 and 2 comma 2 which are belongs to your relation. So what is the result for that? 1 comma 2, it is your result by using the transitive property. But 1 comma 2 which are also available in your relation. 1 comma 4 and 4 comma 1 which are belongs to in your relation. By transitive property, what is your result? 1 comma 1 which is 1 is related to 1. It is your result by transitive property. 1 comma 1 which is also belongs to in your relation. Okay. Same get apply for here 1 comma 4 and 4 comma 4. which are belongs to in your relation. It is implies for that 1 comma 4 is also belongs to in your relation. This by using the transitive property. A is related to B is related to C, then A is directly related to B. This is your result that is also available in your relation. So next combinations is become 2 comma 1 and 1 comma 1, which are belongs to in R. What is transitive property is talking? 2 is directly related to 1. Okay, this is the result. 2 is directly related to 1 and which is also belongs to in your relation R. 2 comma 1 and 1 comma 2, which are belongs to R. By transitivity property, 2 is related to 2. 2 is related to 2. This is your result. 2 is related to 2. And 2 comma 2, which are also available in your R. But if you are checking this 2 comma 1 and 1 comma 4, which are two different elements which are belongs to in R. What is the result are coming by using the transitivity property? By using the transitivity property, 2 is directly related to 4. 2 comma 4. But if you are observing the original relation, 2 comma 4 does not exist in your relation. Let us observe for that. 2 comma 1 is available or not. 2 comma 4. 2 comma 4. What is 2 comma 4? Let us observe for this. 1 comma. These two different element. Let us observe these two different element. What? 2 comma 1 and 1 comma 4 are two different element which are belongs to that relation. Means A is related to B, B is related to C. Then what is transitivity property talking about? A is directly related to C. Means 2 comma 1 and 4 comma 2 comma 1 and 1 comma 4. These two different element which are belongs to R. What is the result for coming? Result are coming 2 comma 4 by applying the transitivity property. But 2 comma 4 does not exist in the relation. If you observe that relation, 2 comma 4 does not exist, does not element. 2 comma 4 are not element for our relation. Okay. Then we are concluded that there exists one pair in the relation. There exists one pair in relation. That pair does not satisfy the transitivity property. There exists a pair. That pair does not satisfy the transitivity property. That pair does not satisfy transitivity property. Therefore, we directly say that R is not a transitive. We can directly comment R is not a transitive relation. R is not a transitive relation. Okay. Today's we are ending these lectures and we are stopping. Okay. Thank. Next lectures we are continuing the next question.